Okay, so we're going to be looking at the washer method, okay? So before we want to start that, but I want to show you how it works and it's different than the disk method, okay? So what we're going to be doing here is we're going to be solving this problem here. Find the volume of solid generated by revolving the regions bounded by these functions around the x-axis, the y equals 0. Okay, so let's start with the basics. So we've got to find that area. So you got this, here's your y equals x. Then y equals 0, that is your x-axis. Y equals 4. 1, 2, 3, 4. So this here, like that. And then x equals 3. 1, 2, 3. Like that. Okay? So basically, we're revolving this piece right here. Okay? Taking this area and we're revolving around here. Okay? So to kind of see what it looks like, I'm going to reflect this. So this point reflects over to here. This point's here. So it looks like this. So this rotates like this, and this point rotates like this. So basically we're making a cone, okay? And the equation that we're going to be using, since it's horizontal revolution, looks like this, integral from a to b. This is r in terms of x squared dx, okay? Now, your radius, r in terms of x, is going to be your function on top minus the function on the bottom. So if we look at one radius here, like this right here is my r. My top function is going to be x, and the bottom function minus 0. And my volume starts here, the rotation starts here at 0, and ends here at 3. So when we set up our integral, it is going to be pi from 0 to 3 of x minus 0 squared dx. Okay? So this is if we were doing disks. Now, what makes it disks is that my solid, there's no gap here in this original area right here. See how there's no gap between my area and my axis of rotation. So this is sitting on my axis of rotation. Okay, so this is disk method. Now, we're going to take the same solid, almost, okay, and look at it a little bit differently. So now, still taking y equals x. So here's my y equals x. Then y equals 0, still right here. X or y equals 4, 1, 2, 3, 4, right here. And x equals 3. 1, 2, 3. Okay? Now, we're still using this same area. Okay? Now, here's the difference. This area now, okay, and I'm going to change this to blue so it matches what's up there. And then this is this area. Okay, the difference in this one is that we're going to be revolving the solid around the y equals -2. So that's this line here. So I'll draw -2 right here. Okay, so this line here is where my rotation is going to be. Okay, so here's the difference. We're going to be taking this area right here, and we're revolving it around this axis. Notice it's not the x-axis anymore, it's this line. So I basically do the same thing I did in the last one. I reflect what I have over my rotational line. So this point reflects here, this point reflects here, and this point reflects here. So here is this right here. That matches up with this part here, reflected over my rotation. When we do our rotations now, you can see, look. And if I took one of these, and I'll do it in a different color so you can see it better. I'll do it in purple. If we look at this, as it rotates, or if we pick any other point, a cross-section taken out of here is going to look like this. It's going to have a big hole in the middle. Okay? And if we look at this equation for the disk versus the washer, a washer looks like this, from A to B, and it's big R minus little r squared dx. Okay? Where this right here is the big radius, and this one here is the small radius, which basically comes from this. This right here, this is little r, and this right here is big R. And this kind of goes back to that whole, when you did it in geometry, where they said find the area of the shaded region, where you had to find the area of the big circle and subtract out the area of the smaller circle. That's what we're doing here. Okay? So when I look at my disk, this right here, from here to here, from here to here, all the way out, this is my big R. Okay? Then from here to here, this is my little r. Okay? The equation's still the same. And I'll use green so it's better. Big R of x is still the top function. So what's the top function here? That is my y equals x. So it's still going to be x minus, where's the bottom? That's -2. And little r is still going to be top minus bottom, but in this case, our top is 0, because this is y equals 0, and the bottom radius is -2. Okay? And then we just plug those in. And again, our volume still starts here at 0 and ends at 3. So it goes from 0 to 3. And our big one is going to be x plus 2 minus our little one, which is going to be 2. And then all of this squared dx. Okay? So here's the thing you have to realize, is basically the shape that we've made is nothing more than a shape that we've done a bunch of times. This is what we call a truncated cone, but it's got a hole in the middle. It's got a cylinder pulled out of the middle, and that's what this is. This is basically saying, okay, we're going to take the big cylinder minus the cylinder that's from the middle. And that's the difference. The only difference is that in this one, we only have to worry about one radius because it's completely full in here. But in this one, we're basically taking this whole solid from here to here and then backing out this piece from here to here, just like we did here. Okay, that's the only difference. So we're basically doing the same thing, except it's got a hole in it. Your code for today, for my classes, is F1N1SH3D. F1N1SH3D.